Okay, so I want to do a quick video and go over some converter stuff. I'm going to be as quick as I can, but there's a lot of stuff to go over. So the first thing that we're going to talk about is converter size. So if you're trying to compare converters, or say you're trying to buy a used converter for your existing car combination, or you had a racer that was hauling ass at an event and he told you a little bit of info about his converter, you're not going to be able to figure much out unless you know everything about his converter, because there's a lot to it. Excuse me. The first thing is, what converter core are you using, or is that person using? You can't measure them with a tape measure. The best way is to do a visual ID. Most converter guys are going to be able to look at the different converters and figure out what they are just by looking at them. I'm getting to where I can kind of do that. Like, I know this is a GM245 converter, which is a very popular converter. I mean, I have a ton of them here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 that I can see by standing right here. So very, very popular converter. And for good reason. It's a very versatile converter. It works in a lot of different combinations. But if you were to compare like this converter to like the 252 Nissan, which I have a bunch of these here too, they're apples and oranges different converters. They're not even close to the same as far as how they're going to behave. So if you were to build a 245 Nissan or 245 GM and a 252 Nissan and build them exactly the same, like the pump angle and the stator design and the clearances and all that, the 252 Nissan is going to be so much tighter, just because of the way that converter behaves. And it's not necessarily because of the size, but the size is the main thing. The main rule of thumb is the bigger the converter, the tighter it's going to be. So, but there is more to it than just that. So the next thing, once you figure out what converter size you have or what converter size you need, the next thing is the tip of these blades. So this piece is called the impeller or the pump. And the more positive these blades are, so if you're looking at the blades at the 12 o'clock position, the top, the more the tips of them are bent over to the right, the tighter your converter is going to be. Different converter manufacturers use different numbering systems to designate how tight their pump is, okay? There's no standard to any of that. PTC uses a couple different numbering systems, even within their own converters. So on PTC's 9.5 TH, which is built out of a 252 Nissan core, and their 10 TH 258, which is built out of a 258 GM core, I've seen 3 numbers on those. They might have more, I don't know, but I've only ever seen 3. -0 is the tightest, -1 is looser, and -2 is looser than that. And again, that refers to how far these tips are bent over. I was told by the previous owner of PTC, I don't know the new owners, but I imagine they're good folks because, as far as I know, they bought the place and they're doing an awesome job over there making converters still. Anyway, the previous owner of PTC, who I knew pretty well, told me that the -0 meant it was bent over about 1/4 of an inch. I don't know if that's true or not, but and then the -1 would have been bent over about half that, so around 1/8 of an inch, and the -2 would have been bent over, or not bent, basically not bent. It was basically like a straight up, so a loose pump. On their street converter, so their 10 TH street converter, which is built out of a 245 core, again, their 10 TH 258 is built out of a GM 258, which is a way, way tighter converter than a 245, all else the same. But on their street converters, they use the amount that it's bent, the actual amount. Like they do a +200. +200 is tight, the tightest. And then they go down in 50 thousandths increments. So they have a +150, a +100, and a +50. I don't know if they have any more than that. That's the ones I've seen. But that's the way their numbering system works with those converters. So with the race stuff, the full out race stuff they have, -0 is the tightest, -1 is looser, -2 is even looser. With the street stuff, a +200 is the tightest, and then a +150 is looser, +100 is looser, +50 is looser. That's the way their system works. Chance, for his impellers, he uses angle. So he has a straight, which he calls an SFA, straight fit angle, and then he has an R5, R15, R25, R35, and I think an R45. He's referring to the number of degrees that he has the tip of the fin bent over, okay? So the higher the number, the tighter. So like an R25 would be tighter than an R5. Okay? So that's the first two things. The first two main things. The size of the converter and the size and core of the converter, the impeller tip angle. Those are the first two things that's going to affect the way the converter works. The final thing is the stator. So the stator, and I have other videos that talk about what this does. We're not going to talk about that. We're only going to talk about how changing it affects the stall characteristics. The rule of thumb is the bigger the window, the lower the stall. So think of it as the more you open up this window, the more fluid it can flow. So the more fluid is available to grab the turbine and turn it, which is going to tighten the converter. The more you block off the window, the looser it's going to be because you're blocking that flow. But also the more you block the window, the more fluid it's going to grab, because again, it's grabbing the fluid instead of letting it flow through. The higher the stall speed, the higher the stall torque ratio. So that's how I kind of remember it, is the more you open up the window, the more window space you have, the tighter it's going to be. So how do you open the window? You remove blades. So if you go from an 18 blade down to a 14 blade, that's going to tighten the converter, right? Because you have more window now because you have less blades blocking the window. Also the degree of the blades. So the more laid down they are, the more it blocks that window, looser. The more laid open they are, the less it blocks the window, the more opening it has, tighter. That's the way I always remember it. That's only true for like the straight blade hand fab stuff. So that's another thing I want to throw out there to complicate things, is if you have an airfoil style stator like this one, this is just a cheap cast 082 245 millimeter stator. If it's an airfoil design like this, all that just goes out the window, because on the within this particular 245 core, the 14 blade is way looser than the 21 and 22 blade. Why? It's because it has to do with the way it grabs onto fluid. So the 14 blade, the design of the blade clearly grabs onto way more fluid, and that's going to raise the stall speed. It blocks the fluid flow or grabs it. The 21 and 22 clearly flow more fluid than the 14, and therefore they're tighter. So that rule of thumb with removing blades and adding blades does not always apply when you're talking about the aerofoil style stators. Something to keep in mind. But if you're talking about the hand fab race stators, if they have more blades, they're going to be looser. Okay. One other thing is how they're measured. So pretty much everybody measures them off of this axis, and that's how you would measure the blades if it's not marked, is get an angle gauge and measure the actual blades from this angle here. So a 35 would be 35 up from this angle. One other thing to keep in mind is Pro Torque marks their stators from this plane. So a Pro Torque 55 is measured 55 degrees from the transmission shaft axis. So that would be the equivalent of a 35 degree from PTC or Chance. So something to keep in mind is that not all converter companies measure that angle the same. So hopefully that's complicated enough, because it's just that's as simplified as I can make it. There's just a lot to this stuff. So another just kind of general example, just to kind of go over how much different the two different converters can behave, or two different converters can behave. If you jumped from a 252 Nissan up to a 258 GM, you would have to add 3 or 4 blades to the stator to make it behave anywhere near the same. So example, if you had a 1535 252 Nissan converter and you went to a 258 GM because you got a good deal on a converter or whatever, you would have to put like an 1835 or 1935 or maybe even a 2035 in that 258 to make it behave anything like that 252. That's how much different those two converter cores are, with only 6 millimeter different in actual size, physical size. Because again, there's more to it than the size. The number of blades on the turbine, which there are actually a couple turbines, like even for the 252, that behave different. But I think most everybody's going to use the more common one, which I think has 29 blades, but don't quote me on that. But I do know that there is 2 different turbines available for the 252 Nissan, and there could be multiple turbines available for the 258. And again, the turbine is the part that drives the car. They usually don't make any changes to affect the stall characteristics. You change the impeller and the stator. But I was just stating matter-of-factly that there are multiple turbines available for some of the converters. So something to keep in mind, if you're like, oh, I got 2 identical converters, make sure the turbines are identical too, because that could affect the stall characteristics. And then one final thing is the space between the stator and the turbine affects it, like fine tunes the stall characteristics. So like Chance, when they build a converter, they build the shell of the converter like 90 thousandths big, and maybe more in some instances, but I know the ones I've messed with are they build it 90 thousandths big, and then he puts 30,000 shims either behind or in front of the turbine, depending on how he wants to affect the stall. So the more he moves the turbine up into the stator, the tighter it gets. The more he moves it away, the looser it gets. You can also find often that builders will go in here and mill 100 thousandths or 150 thousandths out of the turbine side of the stator fins. They'll just come in here and mill each one of these. That will raise the stall speed a couple, 100 RPM or whatever, depending on a bunch of other factors. But that's another modification, is to mill the stator to put a little bit more of a gap in there. So, so the size, the impeller tip angle, the stator design, and then the gap on the stator. And then the final thing, which isn't a factor very often, is the number of blades on the turbine, because as far as I know, they try to keep that consistent. So that's all the stuff that you got to look at when you're trying to spec out a converter. And that's why we say it's best to just get a hold of your converter guy and let him do it. I've been trying to get a handle on this stuff and learn it, but there's so much to it, and things just keep popping up. And these converter guys that do it daily will tell me stuff, and I'm just like, holy crap! So the really smart guys that have helped me out a ton with these is John Hutchinson up in Canada, Pete at Circle D, who used to be at Hughes, Pete Nichols, Marty Chance at Neil Chance, any of the guys at PTC. I don't know any of the new people, but I've been told they all know their stuff. And Joe at Pro Tour. Sorry, Joe, I should have mentioned you already. Joe Riviera at Pro Tour. All those guys are very helpful. Obviously, they're going to want you to buy a converter from them, and I totally agree. Like, if you call me up and get a bunch of info from me on transmissions, I would prefer if you bought a transmission from me. I mean, if you don't, that's fine too. Maybe bring it to me for a freshen up or something. I don't care. But I'm just saying, most of those guys, if they go through all the specking and all that stuff, are going to want to try to sell you a converter and have you stick with their converters. And it's not because they're just being greedy and they want everybody's business. It's because they know what works with their line of converters. So, like Marty he has some converter cores that he prefers, and there's, his stators are designed a certain way, and PTC stators are designed a certain way, and, some of the stuff kind of crosses over. Some of it's very similar, but they all kind of have their way that they are building them, and not because they think it's better or because of this or that, or you can say whatever you want about any of those guys, but any of the people that I mentioned are going to be building winning converters. And there are more, too, that I didn't mention. Slack, Cameron has got really fast stuff. Mickey has got super fast stuff. ATI has got fast. Cone's got some crazy converter stuff. So pick your company. Any of those ones I mentioned are going to build you a badass converter. And there's even more. FTI has got stuff in the winner circle right now. There are a ton of them out there that build badass converters. You just have to remember that you can't compare like a Chance converter straight across to a Pro Torque. You just can't do it. Like it doesn't work that way. They're all just enough different that you got to kind of try to compare apples to apples, or at least know the differences in them. Like I talked about with the stator angle. Something as simple as that could really throw somebody off. That you're measuring the stator angle from a different axis. So and that makes a big difference. So just keep all that in mind when you're trying to compare converters.